All right, good morning everyone. Hope your day is going well so far. Today we'll be talking about matrix multiplication, which is a very versatile and useful topic. And FYI, this will be the last topic covered on Friday's quiz, inclusive of this lesson. So again, this is the last lesson slash topic to be included on Friday's quiz. Okay, for your do now, it's to multiply these two matrices, and of course, we haven't done matrix multiplication before, so I want you to make an educated guess based on the context of this question. So here it reads, given the following two matrices, determine total budget for Monday, Tuesday, Wednesday, and Thursday, where T is the travel cost, F is food cost, and E is extra costs. And like, how would you do that? Like, how would you just calculate that based on, I guess, intuition or common sense? And that'll actually be the same way. So this question is like set up so that like it actually gives you an introduction to matrix multiplication. But yeah, see if you can come up with a number, and then we'll review in like let's say 30 seconds. Okay, so let me pause you here. I'm gonna scroll up to the solution. Okay, so yeah, as I said earlier, right, this is kind of gives you an introduction to the method behind matrix multiplication. So by common sense, like for like travel costs, food costs, and extra costs, you would do 3 times 13. And then for the food costs for Monday, you do 4 times 8. And then for any miscellaneous costs, in this case labeled as E, or extra cost, this is 2 times 6. And you would add those together, and then you would get your total cost for Monday, for example. And so this is this is the final answer right here that I'm highlighting: 83, 67, 37, and 75. And again, the way we get that is 3 times 13. So that's the travel cost for Monday. So I guess like the person or I guess group of people, they use 13 units of travel, and then $4 for a food cost, and then this 8 represents, they purchase 8 units of that food, and then $2 for the extra costs, and then 6 units of that extra cost were consumed, right? So that would be 6 times 2. And you do the same thing for Tuesday and Wednesday and Thursday. So 3 times 9 plus 4 times 8 plus 2 times 4. That's 67, which I label right here. And then for the Wednesday column, it's 3 times 7 plus 4 times 4 plus 2 times 0, which is labeled here. And if you add that together, you get 37. And then for Thursday, you get 3 times 15 plus 4 times 6 plus 2 times 3. So that'll be 75. Okay. And in summary, yeah, you would have this matrix right here: 83, 67, 37, and $75. So that would be like the total budget for each day. Okay. All right, but yeah, I'll give you some time to copy that, and then we'll get to the rest of the lesson. So, this is a simple matrix multiplication problem, and but it could get more complicated, obviously, and we'll go through that today. Okay, so again, just take some time to copy this, and then we'll go into the rest of the lesson. Oh, actually, one thing I want to note, so here I use the word dot product. If you remember from early on in the semester or in the year, we talked about the dot product of two vectors. So for that, it was like 3 times 13 plus 4 times 8 plus 2 times 6, right? Another example of that is like work is the dot product between force and displacement. All right, so it's the same operation that we're doing here, where we're taking 342, multiplying that by 1386, and then adding those respective products together. Okay, so with that said, let me move on to the rest of the lesson. So let me give you an overview of what we're doing. So first, we're going to notice something about the dimensions of the three matrices in the do now, and then we'll get to the formal definition of matrix multiplication, and then just some examples. Okay. All right. So something to note here. Let me zoom out a bit. Is I want you to write out the dimensions of the three matrices, and you should notice a pattern. Okay, so this first matrix is one row by 3 columns, right? So that's 1 by 3. And then the second matrix here, Monday, Tuesday, Wednesday, Thursday, like that matrix, this has 3 rows and 4 columns. So we would say this is 3 by 4. And then the last matrix, right, the product matrix, this has 1 row and 4 columns. So something you should notice is that these numbers in the middle, right, this is what allows us to multiply. So only if and only if these numbers are equal, like these numbers in the middle are equal, are we allowed to multiply two matrices. And the reason for that is based in the algorithm or the procedure that we'll see later. But just keep that in mind. These two numbers in the middle, right, they have to be, so the number of columns in the first matrix multiplied by the number of rows, in the second matrix, they have to be the same. Okay, so this, this first matrix had 3 columns, this second matrix had 3 rows, so we're allowed to multiply. And then the outer two numbers, 1 and 4, that will provide the dimensions of the product matrix. So as you can see here, the product matrix is a 1 by 4 matrix, right? 1 row, 4 columns. Okay, so just to reiterate, the two numbers in the middle, they have to be equal in order for the product to be valid, right? In order for us to actually multiply the matrices. Otherwise, you could say that there's no solution. And then the two outer numbers, in this case 1 and 4, those are the two numbers that will be the dimensions of the product matrix. Okay. So yeah, for your notes, just copy this down. And I can specify a little further. Yeah, so we're talking about the do now here. Okay. Oh, let me zoom out. Okay, so while you finish copying that, let me also just get to this. Can someone read this for us, please? So this is not really getting to the, this is just a note about matrix multiplication, and after that we'll get to the examples. All right, we'll go to Grace and then Sani.
Multiplication of matrices. Note the product of AB of two matrices A and B is defined only when the number of columns in A is equal to the number of rows in B. If A is m times n and B is n times k, then n must match.
All right, thank you for that. So this is just like a summary of what we were talking about earlier, right? So the two numbers in the middle, they have to be the same, right? N must match in order for matrix multiplication to be defined. Okay, so that's something important to keep in mind as we proceed in this unit. Okay, so let me clear the annotations, but yeah, just make sure you copy that down. Okay, that is very important. All right. Does anyone still need to copy the note right here that I'm highlighting? Okay, otherwise I'll move on. Okay, so next we're going to talk about an example, and then after that, just some practice questions. So this note here, you don't have to copy that one. This is just a note for us to say in class. So like, I'm just saying here that the multiplication of matrices is hard to describe. So in the textbook that we have in class, like they actually formalize the algorithm, right? But I feel like it's just easier to just see an example rather than to have to go through all the notation. So I'm just going to show you the example. Okay. All right, so first we have this example here. Let A equal this 2 by 2, 1, 3, negative 1, 0, and then B is this 2 by 3 matrix, negative 1, 5, 2, 0, 4, 7. And we're going to calculate if possible, right? So again, the middle two numbers have to match, right? The number of columns in the first one and the number of rows in the second one have to match. If they don't, then it's not possible. So we're going to calculate, if possible, the products AB and BA. Okay, so AB is equal to, so this is A is a 2 by 2, and B is 2 by 3. Okay, so this product is defined, right? Because 2 matches up with 2. Okay, so we can multiply. So we're first going to, so the first entry right here is this first row dot product with the first column. So the same thing that we did, the same operation we did in the do now. So it'll be 1 times negative 1 right here plus 3 times 0. Okay, that's right here. Okay, so again, this first row right here, let me highlight it. This first row, 1, 3, multiplied by this column right here, negative 1, 0. Okay, so that's 1 times negative 1 plus 3 times 0. Next, so I won't calculate, I won't crunch the numbers for now. We'll do that next. But I'll just give you the entire algorithm. So next we do the first row and the second column. And that'll be the entry right here in the first row and the second column. So that'll be 1 times 5, as you see here, plus 3 times 4. Okay, 1 times 5 plus 3 times 4. Okay, so that's this entry right here. And then we'll move right again to this entry. And for that, it's the dot product of the first row, 1 times 1 and 3, times 2 and 7. Okay, so that'll be 1 times 2 right here, plus 3 times 7. It's right here. Okay, so I wrote it out for your convenience. And by the way, it's actually useful to note the dimensions of the final matrix. So like AB will have dimensions, as we noted earlier, right, it has the dimensions of the outer two numbers, so it's 2 by 3. Okay, that'll help you like know how to draw your matrix. Okay, all right, so now we're done with the first row of the product matrix. Next, we'll talk about the second row. So for the second row of the product matrix, we're going to go to the second row of our left matrix. Okay, so it'll be negative 1, 0, and dot product with negative 1, 0. So negative 1 times negative 1, which is here, plus 0 times 0, which is here. Okay, so negative 1 times negative 1 plus 0 times 0. All right, now we're going to move right. So we're still in the second row, right? So it'll be negative 1, 0 times 5, 4. Okay, so negative 1 times 5 plus 0 times 4. So that'll be negative 1 times 5 plus 0 times 4. All right, the last entry is the second row, third column. Right, and again, this will provide the entry that's in the second row and third column. Okay, so that'll be negative 1 times 2 plus 0 times 7. Okay, so negative 1 times 2 plus 0 times 7. And that'll be right here. Okay, and after that, I'll just crunch the numbers. So you get negative 1 plus 0, which is negative 1. Then 5 plus 12, which is 17. 2 plus 21 is 23. And then here we have positive 1. Next entry is -5, and then the last entry is -2 plus 0, which is -2. So this would be your answer for AB. Okay. And then for the second part of the question, we have BA, but BA is not defined because the dimensions of B, right? B is a 2 by 3 matrix, and A is a 2 by 2 matrix. And note that these two numbers in the middle do not match. Okay, so 3 does not equal 2, so we would say that this product is not defined. Okay, all right, so if that seems a little confusing, that's okay, that's totally fine, right? You know, as your first time seeing it, it naturally can be. But after a few times of seeing this algorithm, just like, you know, with Gauss-Jordan and Gaussian elimination, right? You'll see that, yeah, it's not that bad. Okay. Does anyone still need to copy this solution right here? Okay. Then I'll go on to the next question. All right, next question is this example here. Leo, can you ask your question aloud?
So the outer numbers are the product's dimensions, right?
Yes. So the outer so like in let me scroll up. Yeah. So for example, like AB, here we had the outer numbers were 2 and 3, right? So AB will have dimensions 2 and 3, 2 by 3. Yeah. Yeah. So the inner numbers define whether the matrix is defined, and then the outer numbers determine the product. Okay. All right. So let me scroll down for this example. And let's aim to just solve question 1. So A is a 3 by 2 matrix. And let me not write that. Yeah. So A here is a 3 by 2 matrix, 3 rows and 2 columns, and then B is a 2 by 2 matrix, right? So therefore the product matrix will have dimensions, the outer numbers, right? 3 by 2, which is noted here. Okay. So again, for the first row and the first column, we take the first row of the left matrix, dot product with the first column of the second matrix. Okay, so the matrix on the left, we always work with the rows, and then the matrix on the right, we always work with the columns. Okay, so here we have 4 times -1, which is right here, plus 1 times 3. Okay, so that's this entry. And then next we'll do, we have to multiply this row by the next column, which would be 4 times 2 plus 1 times 1, which I note here. Okay, so now that we've multiplied the first row by each column in the second matrix, we're done with the first row. Now we move on to the second row. Okay, so that'll be -3 times -1 plus 0 times 3. And I note that here. Okay. And again, I'll crunch the numbers afterwards. Next, we have this second row here times the second column. And again, you know, the pattern here is that will provide the second row and second column entry of the product matrix. Right, so -3 times 2 plus 0 times 1, that'll be right here. Okay. All right, now that we've multiplied the second row by each column in the second matrix, now we're going to multiply the third row. Okay, so the third row is 2 and -1, and we're first going to multiply that by -1, 3. That's the first column. So 2 times -1 plus -1 times 3. Okay, so 2 times -1 plus -1 times 3. Okay, that's this entry. And then lastly, we have the last row, third row, times the second column. So that'd be 2 times 2 plus -1 times 1. Okay, that'll be right here. Okay, and after that, we just crunch the numbers. So we have -4 plus 3, which is -1. Then 8 plus 1, which is 9. Then 3 plus 0, which is 3. And then -6 plus 0, which is -6. And then last row, we have -2 minus 3, which is -5, and then 4 minus 1, which is 3. Okay, so that'll be your answer for AB. Okay. The other part of this question was to calculate BA. Note that BA is not possible, just like the example, right? Because of the dimensions, right? So B has dimensions, let me write this out, 2 by 2. And A has dimensions 3 by 2. Right, and since the inner numbers do not match, right, 2 does not match with 3, we cannot, the product would not be defined. Okay, so I'll stop there. So we won't get to the second example, but as always, I'll post the lesson plan on Google Classroom if you want to look at it for extra practice. But for now, just copy this. Maybe. It might seem difficult now, but you'll see that it's not that bad. Yeah, just another algorithm that we had to talk about. Yeah. Okay. Last thing I wanted to mention regarding this lesson is note that matrix multiplication is not commutative. So in other words, like AB does not necessarily equal BA, right? As we see in this example, right? AB is defined, but BA is not possible, right? So, whereas like regular numbers, right, it is commutative, right? Like 3 times 3, or sorry, not 3 times 4 is equal to 4 times 3, right? They both equal 12, right? So note that matrix multiplication is different. It's a different system, so it's not commutative. Okay, all right, that's just something to note that you can see from this example. Anyways, let me close with announcements. One, there's SGI today per usual, 2:47. Secondly, a reminder that our next quiz is this Friday. Okay, so please check Google Classroom for the topics. But yeah, other than that, if you're done copying this and you have no further questions, I'll let you go here and I'll see you tomorrow. All right, take it.
Good day.
Thank you.
All right.
Thank you.
You too. All right, bye-bye.